So, what is this a transmission substation? Again transmission, there are 3 types of substation which are being classified. One is the transmission, the second being the distribution substation, and the third being the collector substation. We will discuss very briefly about each of these substations. So, transmission substation, we know that the modern substations are implemented based on the standards which are being prescribed. It could be international standard, IEC Electrotechnical Commission, International Electrotechnical Standard reference number 61850. This applies to the transmission substations. We also have the rules laid out by the respective Indian standards also. So, as per the Central Electricity Authority guidelines, these substations are implemented and constructed. So, a transmission substation connects generally 2 or more transmission lines. So, that is a point. The simplest case is where all transmission line have the same voltage. If the transmission substation could be operating at a same voltage, say 400 kV or a 765 kV or a 220 kV and so on, simplest case. But the substation can range from a simple to a complex. So, the same substation, it could receive 765 and it could also have a 400 kV out lines, so on. So, there could be a different level of voltages which are operating, and it could be a simplex to the complex substation in the transmission substation. So, the largest transmission substation could cover several acres or hectares with multiple voltage levels. It could include many circuit breakers and a large amount of protection and control equipment. This again, protection and control equipment consists of the voltage transformer, the current transformer, several relays. It could involve the SCADA system and communication network. So, the typical transmission substation is shown here, consisting of different type of circuit breakers, the protection equipment, the control equipment, and the control arrangement which has been done for a typical transmission distribution. This could expand over a wide area, could be having several acres, a few acres to tens of acres, depending upon the voltage level and depending upon the complex nature of the voltages which are being considered. So, second is the distribution substation. Again, the distribution substation, the main function of the distribution substation happens to be to transfer the power from the transmission substation to the distribution substation. So, the distribution substation reduces the voltage to a value suitable for the local distribution. So, this local distribution typically medium voltage levels anywhere between 1 kV to 66 kV, 1, 11, 33 or a 66 kV. Again, this depends mainly on the size of the area which is to be served, where the loads have to be catered, and also the practices which are being carried out by the local utility or electricity authorities of the local state or district level. So, in addition to the transforming voltage, the distribution substations also isolate faults, that is very important, in either the transmission or the distribution substations. So, very important. So, distribution substations not only caters to the local requirement anywhere between 66 to 1 kV, and it also tries to isolate the faults which could happen because in the transmission or the distribution systems. This is a typical example of a distribution substation. Again, this consists of the various components associated in the substation, like the protection of CTs, the current transformers, the potential transformers, the equipment which protects like the surge arresters. You have various relays and all these aspects here, and the transformers, that is very, very important. The third is classified as the collector substation. This collector substation is basically in distributed generation. It is being such as the wind farm. Here this type of substation is being seen or adopted, where a collector substation is required. It similarly resembles like a distribution substation, although power flow in this is in opposite direction. So, here the point to be noted is because the collector substation provides a power factor correction and also metering, the control particularly for the wind farms, and in some cases a collector substation can also contain a high voltage DC static inverter plant. So, the collector substations do exist where multiple generations like the thermal or hydroelectric plants or a comparable output power are in the proximity. In such cases, the collector substations play an important role in combining these generating plants and trying to transmit the requirement of the power to the required loads. So, if no transformers are required for increase of voltage to the transmission level, the substation is generally termed as a switching substation. So, in case only activity where the loads are to be catered, in case it is known as a switching, it is not a collector substation. So, next we have discussed about the air insulated substation. All the previous information which have been discussed is the air insulated substation. You can see this is the air insulated in the sense the open field where the equipment are exposed to the atmosphere. It could be distribution, it could be a transmission substation, it could be a collector substation, or it could be a switching station. So, these are in the atmosphere, open air atmosphere. So, now the advancement in technology has seen that the substation, the compactness of the substation, the compactness of the equipment used for substation has been advanced, which has helped particularly in the areas where the space is a constraint. So, in such cases the gas insulated substation is being widely accepted and widely being adopted, very important at various voltage levels. So, some of the basic concepts for adoption of the gas insulated substation is classified as, mainly because of the reliability of the gas insulated substation is very high. So, this reliability to earthquake and for the pollution or a contamination, because which the air insulated substations are prone are very high. So, while the size of the equipment also enlarges, the cross wise connection could be adopted more easily. See here in case of air insulated substation, the clearance have to be followed and minimum clearances have to be maintained, whereas in gas insulated substation you can see here anywhere the crosswise connections could be adopted, because sulfur hexafluoride is the insulating gas and the clearances are completely or reduced to a drastic level, and the operating for the crosswise connection could be adopted more easily and compared to the air insulated substation is a very important point. And there are about several more than 750 bays of 550 kV outdoor GIS only in Japan, and high reliability of GIS is already confirmed. So, several countries including India are being going in for gas insulated substations. So, we have several gas insulated substations which have come up in the last decade in the country at various voltage levels, and they are functional, they are functioning very well. So, that is the point to be considered. So, the gas insulated substation is advantageous particularly in the environmental conditions, because it has less influence on the environment caused by the construction, and this going in for gas insulated will decrease the corona noise, which was noticeably seen in case of air insulated substations. And second important point being the less influenced or less noise caused by the electromagnetic compatibility. So, less EMC, this is very important point to be seen. So, the basic concept to adopt gas insulated substation should be made is to see that it is compact and as possible to see to reduce the construction cost of the substation, that is very important. And going in for this, so to reduce the lightning impulse withstand voltage, lightning impulse withstand voltage by arranging high performance surge arrestor could be done, and also is determined by analyzing the lightning surge. So this can be again considered to reduce the cost. So lightning impulse withstand voltage is decided as a 2250 for gas insulated substation and 1950 kV for a transformer for a particular voltage level of mentioned shown here in the table. So specifications, when you consider 1100 kV GIS arrestor, the highest system could be 1100 divided by root 3, and lightning impulse residual voltage will be 1620 kilovolts at when the current is passed 20 kilo amps. So lightning current of 8 by 20 microseconds is passed to the disk or arrestor of 1100 kV. So 1620 should be the residual voltage, and the lightning impulse withstand voltage in case of transformer should be 1950 kV, and the gas insulated substation should be 2250 kilovolts are the specification for GIS. So this is a typical gas insulated substation which is being seen here. It consists of a transformer, gas circuit breakers, the bushings, gas surge arresters. So all are sulfur hexafluoride gas as the insulating media, which reduces the entire cost, and it is very compact. This is one of the example of a 400 kV GIS station which houses several switchgear and the bus duct. So a very compact size, a 400 kV typical substation will have several acres in the open air. Here it is less than 1/10 of the required area in case of the air insulated substation. So this is a similar comparison of an electrical high voltage substation. You can see this air insulated substation which has exposed to the atmosphere a lot of clearances and several complicated arrangements have to be carried out, whereas for the gas insulated substation it could be very compact, and with the help of the sulfur hexafluoride gas it could be made compact. So we will compare various substations importance, comparison of air insulated switchgear substation. So generally air insulated substations are installed outdoor, that we have discussed. So air insulated substations uses atmospheric air as a phase to ground insulation. So air is basically used as an insulation, that is the clearances from the metal to the ground is being maintained with the insulating media being the surrounding air for any switchgear. The main advantage of going in for air insulated substation is the scope for future offloading. In case the substation has to be upgraded from a particular voltage level to the higher voltage, as it is not a difficult arrangement could be made for the upgradation. So for this reason air insulated substation tends to be more popular in case of 400 kV substation or higher voltage levels. And the equipment of an air insulated substation is easily sourced because several players are available who can supply the equipment pertaining to the air insulated substation. That could be switchgear, circuit breaker, isolators, surge arresters, transformers. So basically many manufacturers are available in several in the country and abroad, where you could get the equipment without much of the difficulties. So and also has a short lead time, means that the required future offloading does not need to build immediately unlike the gas insulated substation. So this is several advantages of going in for air insulated switchgear. The main disadvantage of going in for air insulated substation is mainly because of its overall size. Say example, at a 400 kV level, these substations can have a significant footprint and could require sensitive locating in any rural environment, but in the places of thickly populated and the places in the metro cities, getting the land for the substation could be of a very difficult or it could be a tedious job for getting the land. So, because of the high cost involvement, so the air insulated substations building particularly in the thickly populated and where the land prices are very high could again increase the cost of the substation. So, gas insulated switchgear substation mainly as earlier mentioned uses sulfur hexafluoride gas as the insulating medium, SF6 gas as the insulating medium. The dielectric properties, the insulating properties are higher than the air and they provide the phase to ground insulation here. So, cylinder containing the SF6 gas with the conductor at high voltages and filled with the sulfur hexafluoride gas acts as a dielectric or a insulating media to provide the clearances required to phase to the ground insulation. The main advantage of going in for gas insulated substation is the phase to phase spacing can be reduced significantly, resulting in a substation with comparable load capability to the air insulated substation. So, that is one of the main advantage, the spacing could be reduced. This further reduces the load and the comparable size of the substation, and particularly this is advantageous as mentioned in urban environment and the place where the land size is at a premium or a very cost. So, in such cases it also results in smaller visual impact on the landscape, that is very important point. But the main disadvantage of the gas insulated substation type is a reduction in scope of the substation for future offloading, as the equipment can be costly and again difficult to source over a long period of time. So, gas insulated substations have to be properly planned for a future requirement, else immediate going in for change or going in for upgradation would necessitate the economical constraints. That is a very important point to be considered. However, with several installations as mentioned of gas insulated substations coming up globally and also at the country level in India, several utilities are installing the gas insulated substations up to 400 kV levels. So, presently several manufacturers are available with the gas insulated substation equipment, and in future the sourcing of this required equipment may become less onerous and also less costly, that is it could be more economical in future because of number of manufacturers going up. So, as a rule gas insulated substations are generally installed in indoor, that is a very important point, it is not an outdoor substation. However, outdoor GIS also has been installed in the recent past and again they are becoming a more common option. So, both indoor and outdoor and there are also hybrid substations which partially the transformers being in the outdoor yard and the GIS technology for the switchgear and the bus duct. So, air insulated, gas insulated and also hybrid insulated substations are being constructed depending upon the economic considerations with the utilities. So, air insulated substation, the minimum size of an air insulated substation, overall substation compound, these are some specifications for a 400 kV level. When you compare both air insulated and a gas insulated substation, you can see the overall substation size could be anywhere 11.6 acres is a requirement for the land to build a 400 kV substation. The switchgear is air insulated in outdoors, and therefore no building sizes are considered here, because all the entire switchgear is kept in the open yard, and only the control arrangement is the building which is to be housed the control gear and the protective relays and so on. Whereas in gas insulated substation, the size is based on the gas insulated and the building sizes would be for a 400 kV typically is 12 meter by 43 meter could be sufficient for the 400 kV GIS station. The size of 110 kV building could be only 27 by 10 meters, and height of 400 kV building is generally 11 meters, whereas here if you see the compound and the height is 28 meters. Here it is lesser than 50% of the height which is required for the gas and air insulated substations. So, the overall size when you look approximately for the gas insulated substations is typically around 2.5 to 2.6 acres of land is required for a 400 kV gas insulated substation, whereas for air insulated anywhere between 11.6 to 12 acres is a requirement. Drastic reduction more than 5 to 6 times in the overall land availability going in for GIS substation. About the maintenance and operational flexibility is very important point. So, like any electrical equipment, it could be air insulated or a gas insulated switchgear. These require continuous maintenance, very important, because the maintenance is done normally to prolong the life of the equipment or the insulation of the equipment, so that it lasts for a long period of time in the service. So, the annual service cost in comparison for both air insulated and gas insulated are identical in nature. The costs only vary with switchgear, that is given in a detailed service maybe after 20 to 24 years, but this will need the manufacturer's assistance. So, the annual maintenance cost remains both are same. In case of air insulated substation, the maintenance requirements could be for the ongoing maintenance of the equipments which are exposed to weather conditions or climatic conditions. And in case of circuit breakers, the disconnect or isolator, the disconnect contacts must be cleaned regularly, and the maintenance has to be carried out regularly for the operating mechanisms, and also must be verified and maintained at a regular intervals, that is very important. In case of GIS, similar maintenance requirements, the arrangements of the switchgear play a significant role, particularly in the maintenance to be carried out, and also the considerable dismantling may be required in case if a main element of an equipment fails. So, here the point to be noted in the air insulated substation, the local knowledge or the local idea could be available, and the problem could be solved, but whereas in case of GIS maintenance there is a requirement from the personnel, from the manufacturer, as the supervision will be required for the 20 full years, as the manufacturer presence is of utmost importance, particularly in case of the equipment or any element failures. The changing of the equipment or the element has to be done in the presence of the manufacturer supervision, very important point to be considered. So, this shows the comparison of hybrid and high voltage substation. So, gas insulated substation, air insulated we have seen. So, hybrid is a combination of the air insulated and the gas insulated. The important point being again it reduces the economy to a certain extent. Going in for full GIS could be more costly. So, in some of the cases the transformers could be installed in the open yard, that is outdoor, and rest of the equipment could be of gas insulated, though this drastically brings down the cost of the transformer which could be of gas insulated GIS. So, this type of substations are also being considered and also being established by the utilities at different parts of the country as and also the globe. This is the typical example of a hybrid type of substation. So, hybrid, as mentioned again, the term refers to the combination of both the conventional, that is a air insulated switch gear, and the new one, that is a metal clad or the gas insulated switch gear, which was we were discussing. So, the solution, the hybrid solution, uses existing tried and trusted gas insulated components together. So, very important, it uses both technologies with a conventional and also a extremely reliable air insulated bus to connect various hybrid modules. So, here all the necessary substation switch gear, including the bay functions and a circuit breaker are combined in one or more forms, like a disconnector or the earthing switches. The bushings to the connections could be of single or a double bus bar systems, and the measurement like the current transformer or the potential transformers could be integrated into one compact module. So, this is the hybrid arrangement, and it is seen that the eliminating the need for a separate pieces of equipment for each function is normally done. So, what are the advantages of going in for this hybrid substation? So, hybrid substations, you have the air insulated substation bus bar, that is the bus bar is relatively inexpensive while offering a proven reliability which has been used for the long period of time. All live contacts in sulfur hexafluoride, that is SF6 experience has shown that air insulated substation disconnector switch contacts require relatively high level of maintenance. So, while experience with the GIS is exactly the opposite. So, this could be reduced in going in for gas insulated switch gear. So, the use of SF6 or sulfur hexafluoride technology makes the hybrid switch gear virtually maintenance free, very important point to be considered. This will combine with a high level of reliability to ensure the lower global life cycle cost going in for the hybrid. And the hybrid substation has a fewer switching elements because this uses the gas insulated technology and allows a rationalization of the switching elements. And also the factory pre-assembled and tested, the hybrid modules are fully pre-assembled and tested in the factory. And for monitoring and online diagnostics, the use of the electronic monitoring and online remote diagnostics are also available by going in for the hybrid substation. So, several advantages of trying to reduce the cost in comparison to the full gas insulated or a completely metal clad gas insulated substation. So, substation modularization, again a modular approach to the substation design offers cost and time and also savings during the design and construction phase. Space saving and reduced civil works. So, the hybrid design can save up to 70% of the space which is required conventionally, like the air insulated substation. So, going in for hybrid could be reduced by 70% of the space, and also it reduces the need for civil work such as foundations, the steel work, and also the cable trenching operations, etc. so on. The combined disconnector or earthing switches, here again the mechanism has to be a minimal number of mechanical components and is intrinsically more reliable, and this will be maintenance free. So, this combined disconnector switch operations could be also very useful when you go for the hybrid type of substation. And in case of transportation, there is no special arrangements which are needed for the shipping and transportation. It is much easier like the air insulated substation. So, substation capital costs in comparison of these three technologies. So, the common costs for both the air insulated and the gas insulated options are mainly the high voltage power transformers, very important components, the protection systems, this could be several CT current transformer, potential transformer, the surge arresters, the isolator switches, several relays and the SCADA arrangements, the professional fee, design fee and other miscellaneous items. All this come under the capital costs when the planning is being carried out for any substation. These costs under comparison are civil, high voltage equipment provision and also installation. The material costs are based on either the internal database of the term contract materials or the manufacture cost for a specific project and a specific voltage level and going in for what type of substation is to be adopted. So, the cost comparison between the air insulated, the gas insulated types substations is again a very difficult comparison. This depends on the area where this is to be compared. So, comparing the air insulated and gas insulated in general may be of a difficult scenario. It could be compared only where the in case of the metro or the thickly populated areas, in such cases where land is of a prime cost. So, in such cases the comparison could be made. In case the land availability is at a less economical or less cost, the comparison may not be the correct thing to be done. So, this comparison cannot be directly compared with the GIS and AIS, and it can be done based on that particular area which is to be carried out. This generally this graph, you can see it shows a general comparison diagram for 3 technologies, gas insulated, air insulated and the hybrid insulated or going in for that hybrid substations. This shows the cost ratio in the y axis and the surface ratio. For various bus bar, the comparison has been made for 145 to 245 and a 400 kV bus bar with single and double bus. You can very clearly see the comparison going in for a complete gas insulated substation. The cost will be definitely high in comparison with the air insulated cost, and the surface ratio also has been plotted, and going in for the hybrid could be anywhere between the gas insulated and reduction, substantial reduction comparison to the gas insulated could be seen after the air insulated. So, again the utilities and the planners have to decide to go in for the which type of technology has to be adopted, either fully gas insulated or the air insulated substation which is to be planned. So, apart from this substations, in some of the cases the requirement could be mobile type of substation in emergency and some related requirements. So, in such cases a few of the countries have also adopted the mobile substations for the emergency catering. You can see one typical 245 kV substation which is available in Abu Dhabi, where mobile it could be used in case of the emergency needs. Similarly, for railways in Switzerland, a mobile type of substations is available. These are a few examples in case of emergency requirements.